So, a very good afternoon to you all. So, welcome to the second session of the course program Geoprocessing Overview of Geoprocessing using Python. So, in the morning session, you learnt about basics of remote sensing and GIS. So, today we will start with the basics of Python. So, in this lecture, I will be covering the presentation outline is like I will be covering why do we need Python? Actually, why especially you are using Python for geospatial data processing. Then I will talk about Anaconda, a package manager plus environment manager in detail. Then we will be covering the basic Python syntax, then different data structures in Python, then how do we write control flows and write functions and read and write files. So if you have done programming before, then it will be quite easy for you. But though even you might not have done programming before, then we will try to go it slowly. Then actually you can practice a lot before coming for the next session. So for all the people to come on the same page, we will be covering all the basics of Python right from starting to the whatever we will be using for geospatial data processing. So the first question comes like, what is Python? So Python is an interpreted, interactive and object-oriented programming language. So in today, as of today, Python is one of the most popular programming languages, even in the geospatial data community, geospatial community as well. Plus, actually, Python is very popular among data science community, enthusiasts as well. So Python Software Foundation holds the copyright on Python, and its mission is to advance open source technology related to Python and to publicize the use of Python. So Python Software Foundation only is holding the copyright on Python, and it is promoting Python. So actually there are different distributions of Python available. There is one standard distribution Python is called C Python. So whatever Python you are downloading from the python.org, that is the standard implementation of Python, or is called C Python. Then another popular distribution of Python is Anaconda Python. So we will be using this Anaconda Python during our course, and then later on I will demonstrate you how do we download, install and use Anaconda Python. Apart from the C Python, Anaconda Python, there is another like Active Python, Iron Python, Win9x Python or Portable Python and so on. So there are multiple distributions of Python available. Like these are Python, you will get almost similar functionalities, but they are available from the different sources. So that the two most common are C Python. C Python is the most widely used Python implementation. Plus among data science community, people are using Anaconda Python. So you can use any of the Python. So now the question comes, why do we use Python? So the basic reason is Python is very powerful and fast. Powerful means it has a lot of features available, and though it is an interpreted language, but because of the advancements in technology, it is quite as fast as some compiled languages as well. Plus it runs everywhere. Runs everywhere means Python you write a Python program in any operating system or any platform, then the same program will run on either any of the platform. Like if you are writing program in Windows, the same program can run on Linux or Mac as well. So it runs everywhere. So you can say that Python is an platform independent programming language. So what I feel is the most compelling reason to learn Python is its friendliness and easiness to learn. So Python is the most user friendly and easy programming language to learn. So even whether you are a new programmer or you are experienced programmer, so Python you can learn quite easily. For a new programmers it may take a bit more time, but if you are already using some other programming language, then you can switch over to Python quite easily. The another reason is Python is an open source programming language. So Python's source code also is available. So even if you want, you can, so without paying anything, you can use Python. So you need not pay anything for using Python. Plus Python lets you work more quickly and integrate system easily. So as I explained that Python is very easy to learn. So you can develop complex softwares using Python very quickly. And plus integrate system, like if you have some third-party tools or softwares. Those also can be integrated into the system quite easily. So with the Python, you can access those systems, all third-party softwares, etc., quite easily. So you can integrate multiple systems together using Python quite easily. Plus, Python's documentation, tutorials, and guides are constantly evolving. If you search on the internet, there is a large community support for the Python. So there are a lot of people who are working on the Python, and they are continuously writing new tutorials, guides, or even softwares for using Python. How do you so? And suppose if you are getting into some problem, then there are lot more people are there on the internet to help you out. So those things are continuously improving. Actually, what is happening? Python's new versions are coming quite frequently, and with the new features. So with those new features, your programming task becomes quite easy, and because anyway those documentations are available, so you can learn also those new features quite easily. Now similar reasons are applicable for using Python for geospatial data. As I explained that Python has an extensive ecosystem. So whatever in geospatial data systems, we will be using just a subset of Python programming language. So Python is quite vast. So we'll be using just a small subset of Python for geospatial data processing. Python has an extensive ecosystem of libraries and tools for geospatial data. So there are there is the ecosystem of Python for geospatial data processing is very large. So there are a lot of libraries for vector data processing, raster data processing, creating maps, visualization, and lot. So there is a huge ecosystem of libraries in Python for geospatial data processing. That is one of the most important reasons for using Python. So actually there are a lot of libraries available. So with a minimal amount of code, you can just get started, and you can build very complex processing tools using these libraries, and you need not put so much efforts because already there are many libraries available. Plus Python geospatial libraries are easy to learn, as Python is so easy to learn. Similarly, geospatial libraries which are using Python are also quite easy to use and learn. Then anyways, if Python is friendly and easy to learn, then Python is highly efficient. So Python is very optimized. So there are libraries like NumPy and other things. Very optimized libraries are written in Python. So if your Python code, whatever you write, can be very efficient, and Python is highly flexible. So there are a lot of flexible features in Python, like what I said, that you can incorporate new features or integrate some existing software also quite easily in Python. So you can build the systems quite easily. So actually Python, if you see Python is flexible, it means that Python is available. You can develop any kind of application in Python. So if you want to develop applications for desktop applications also, you can use Python for developing or could you say mobile applications or web-based applications. So any kind of application you want to develop, Python, you can do all kinds of applications in Python. There are a lot of frameworks available in Python for even web development. Actually, even in deep learning also, Python is also the most used programming language. There are many deep learning frameworks also available in Python. Then you can plug in and chain different third-party softwares. So any third-party software which has APIs for Python can be quite easily plugged into your existing system, and those things work seamlessly quite easily. Then Python libraries are developing fast. So new features are coming to Python rapidly. So even in case of geospatial data, so if you see after a month or 2 months, you will see a lot of new features gets added to your existing library. So this way, Python libraries are getting developed very fast, and new features you are getting at very rapid pace. This was the introduction to Python. Now we will discuss about Anaconda Python. So we will not be using the standard implementation of Python, C Python. We will be using Anaconda Python. So Anaconda is one of, like if you have worked in other programming languages, there the programming or the compile interpreter can come from different sources. Like if you have used C, so say there were different compilers like Turbo C or NCCs. So similar way, Python also has multiple distributions which are available from different sources. So Anaconda is one of the most popular Python distributions. So Anaconda is not just a Python distribution, it is a package manager plus an environment manager as well. So package manager means, suppose when you are going to install new libraries to your Python interpreter. So what happens, a library depends on multiple other libraries. So if you are going to install those libraries manually, so you need to install first all the other dependencies, then only you can install the library which you require, because all libraries will be dependent on many other libraries. So package managers help you in installing the different libraries. Then second thing is, Python is an environment manager as well. Like suppose if you have the requirement, like some of your old softwares or libraries are running on the old version of Python, say 2.7 or Python 2.3.0, 3.1. So with the help of environment manager, you can install multiple versions of Python in the same system without disturbing any other environment. So this way, Python is Anaconda is an environment manager also. So it means it helps you in installing multiple versions of Python in the same system. So when you install Anaconda, so Anaconda Python is a distribution with 1000+ open source packages. So once you installed Anaconda, so these 1000+ open source libraries comes pre-installed with the Anaconda. So next comes like how do we install Anaconda on the Windows. So you can go to this link Anaconda, or even on the Google you can search anaconda.com, search for Anaconda, Python Anaconda download or something, you can search for Anaconda Python, then you get the link for that. From that link you can, if I show you, so if I search on Anaconda, so directly depending on your operating system, you can select whichever version suitable to according to your operating system. You can choose, like if you are using Windows, you can download this. Otherwise, if you are using Mac or Linux, accordingly you can download the version of Anaconda according to your operating system. So thereafter you can, like if I see here, I have already downloaded the version of Anaconda here. So once you can just, if you are a Windows user, then you can just click on this and you can follow the instructions one by one. This way you can install Anaconda on your system once, because in my system already Anaconda is installed, so I am not going to do this once again. So once Anaconda is installed on your system, so for using Anaconda, actually there are two modes. So if you are a command line enthusiast, or like if you are using Linux system, so then you can use an version of Anaconda called Anaconda prompt or Conda. So Conda you can use further, like for installing new libraries, creating new environment, and so on. Or suppose if you are not so much comfortable with command line prompt, then you can use GUI based navigator also, that is called Anaconda Navigator. Either Anaconda Navigator if you are more comfortable with using GUIs, and suppose if you are more comfortable using command prompt, then you can use Conda. So either Anaconda Navigator or Conda, any one of the tool you can use for further. So like once Anaconda is installed, you are like, how do you validate that the Anaconda Anaconda got installed to your system properly? So what you can do, you can just go to your start menu and search for Anaconda Navigator. So if you see the Anaconda Navigator here, the Anaconda Navigator starts. So if the Anaconda Navigator starts successfully, it means that your Anaconda got installed properly into your system. So it takes some time to start. So here this is the basic Anaconda navigator. So now the first thing comes, like once the Anaconda is installed, so first it comes with a base environment. Now what happens, as I explained, that Python Anaconda is a Python distribution, a environment manager plus a package manager as well. Now first thing we need to create a new environment in our Anaconda system. So for that you can just go to the environments. So actually here you can see that you see button here, create. Suppose if you have to create a new environment, you can click on create. Then you can give some sensible name to your environment, like suppose I will say for geo processing I want to create a new environment called geo processing. So geo something, geo actually with geo 2 or something. Then from here you can choose which version of Python you want to use. So you can search like 2.7, 3.5, 3.6, whatever version of Python you want to install by default in your new environment. That version of Python you can select. Suppose if you want to support for R as well, then you can select R also, and then specific then the version of the Python or R, sorry. Then you can just click create. Then it creates a new environment. Because in my system actually already I have created a new environment by name geo. So once the environment is created, it will be listed here. So once it is listed, then next you need, for using this environment, you need to activate it. So you just click on this environment. This environment gets activated. So now once this environment is activated here, so here you can see that which all the libraries are installed here. Those libraries you can see here. Similar way, now suppose if you want to install a new library, so then you can go to not installed and you can search for, like suppose if I want to install a new library called GDAL, so I can just search here, or I say PyTorch. Suppose if I want to install a new library called PyTorch, so if I want to install it, I can search here PyTorch, then click on this PyTorch and install. Actually this is on the down, it will be shown installed, or like here, then you can just install that library from here. So this way you can use Anaconda Navigator if you are comfortable using GUI. Then similar way you can search for any library, you can change the version of library installed there, like installed. Then if you want to change the version, so specific version also, like later on you can change. Not installed, updatable, selected, then you can search here and install the library. So this way you can install a library in Anaconda Navigator. So similarly, I suppose if you want to install some Jupyter notebook or something, you can just, we'll talk about Jupyter notebook later. So Jupyter notebook also you can install. So anything you want, you can install from Anaconda Navigator. Now the second option, if you want to use command line prompt, is Anaconda prompt. So same things you can do from Anaconda prompt as well. So for that you can just search here like Anaconda prompt. So Anaconda prompt opens here. Then for this you need to know the few commands, like so next thing, like suppose if you want to know which version of Conda is installed here, so like you can say Conda -- v version. So with that you get to know the version of Anaconda what is installed. Then it's like suppose if you want to update the Conda, so you can see Conda update Conda. With that the Conda gets updated on your system. Similar thing, now suppose if you want to create a new environment here. So for that the command is like Conda create, then you can say -- name, then whatever name you want to give to your environment. Like if I want to say I want to create environment, use name, you have environment with name test, and suppose if I want to install some specific version of Python to that, so then I can say Python. If I don't Python equal to, suppose if I want to install 3.9, so I can say Python equal to 3.9, or like some already other some I want some pre-installed libraries to be installed. So then requirement.txt also I can specify with this. In that I can write the name of libraries which I want to by default to be installed with this new environment. Otherwise, just like you can just give like conda create minus minus name test, and suppose if I want to install the version of that particular Python, so Python equal to 3.9 or 3.7. So that creates a new environment. So suppose if once a environment is created, now suppose if you want to know the names of all environment available in your system, so conda info minus minus envs. So it says that there are two environments created here, one with name base and another is name geo. Or I think conda minus minus list envs also is there, or same command is so some conda list. So conda list envs also is there, one command. So this is once an environment is created. Now suppose if you want to start working on this environment, so first thing you need to activate that environment. So now suppose I want to, because a geo environment is created here in which I have installed some libraries. So suppose if I want to activate that environment, conda activate the name of environment. So when it is showing here geo means a new conda environment got activated. So now in this environment I can start writing my Python code and so on, or I can install new libraries. Like suppose if I want to install a new library called JDAL, so I can here conda install JDAL. Actually there are multiple versions, like you can specify which version of JDAL you want to install by specifying JDAL equal to 3.0, 3.2 or whatever. And actually there is one more option, like JDAL may be available from multiple channels or channels, so you can specify the name of channel also. Now suppose if I want to install this from a community maintained repository called conda forge, so I can say conda install minus c, then conda forge JDAL. Or like if you search it on the Google, then you will get the name of these channels. Like if I say Anaconda JDAL, so like then you can take this command from here and type on your console. So once done this, you can search like this way you can create environment, and then once it is searching, so here you can see that the conda so you can like conda install minus c conda for JDAL, and these are multiple options. So you can use any of these commands for installing that particular library in your environment which is already activated. So similar way, like to find packages you have already installed, you can first activate, then like you can, whether if you want to check like if that particular library is installed or not, you can search conda search JDAL, so it gives whether the library is installed there or not. Like if I say here conda so it says this is available from these functions, this is available, these versions are available from these different packages. Then once search, then you can install that. This is first, once we have installed Python and Anaconda or Anaconda Python in your. So the second thing we will be using here. So actually the Python code can be written in two ways. One is you type all the Python code in the command prompt. So how do we start writing code in the command prompt? Like if we have started here Anaconda prompt. So I'll write here like Anaconda prompt. So then anyway I have created few environments. So first thing I will activate my environment here. Activate, like I'll say geo. So once I am in my active environment, so first thing I need to start the Python interpreter. So as I explained that I can write Python code either interactively on the command prompt, or I can write Python or all of my Python code in a script and I can run that script. So let us see first how do we write commands in a Python prompt. So for that I need to just, once I activated my environment, then I need to just type here Python. So it starts a Python prompt. So here I can start writing my code. Like if I write here the first or the customary code, when you start a new programming language, what we call hello world. So here I will be writing like print print, then I will write hello world. So it prints hello world on the screen. So this is what we have written our first Python program for printing a message on the screen. So this is quite easy. So you just go activate your environment and start Python interpreter by using by typing Python, and you see that this prompt comes, and here you can start writing your code. The second way is you can write the same code in a text file. So I will write here print then once this is written, I will save this particular file with the extension .py. So I will save it on my desktop, all files, hello.py. So I have saved this file. Now suppose if I want to run this file from the Python interpreter, so then I need to write Python and name of the file name of the script file which I want to run. So either I need to give because what happens by default, the Python interpreter searches for the file in the current working directory. So either I need to change my working directory to the directory where my file is available, or I need to give the full path. So this is right now I am not going to change my working directory. I am just going to give the full path of the file. So C drive users / desktop, in that hello.py. So if I run this, you can see that the same lines got executed. So this way I can write my all commands in a script and run that script from the Python interpreter using Python and name of the file in which the code is written. So this was like how do we write interactive code. Now for our classes, but we will be actually there are many more things, like there are multiple IDEs available. So but we will not be using any of these approaches for writing the code. So we will be using one new IDE or IDE for writing the code, that is called Jupyter Notebook. So I will show you how do we use Jupyter Notebook for writing the code. So before that, like what is Jupyter Notebook? So Jupyter Notebook is an open source web application for creating and sharing documents that contain live code, equation, visualization and narrative text. So now suppose if I am going to write a code in a text file like what I showed in a text editor in a simple notepad file. So in that what I can do, I can just write executable Python code or maybe a few comments. But if you write the code in a Jupyter Notebook, so Jupyter Notebook is a web-based application. So there in the Jupyter Notebook, you can not just only write the live code, you can write equations, you can insert images, create visualization in that images. You can write like narrative text explaining your code, and those notebooks you can share with your friends, or you can collaboratively work on a single notebook as well. Like if you are sharing and like Google Colab and other thing, collaboratively you can work on the same notebook as well. You can save intermediate outputs, images, and so on. So like if you are going to use just a simple text editor for writing your code, then you can just write code only. But if you are going to use Jupyter notebook, so Jupyter notebook is Jupyter notebook is also quite popular among people writing Python code. So general convention is like when you are general practice followed by the people is when you are starting your project or program. So generally you write in the Jupyter notebook, debug it, write a lot of documentation about that code, insert images, and so on. So once your program or your software reaches some maturity level, so thereafter you can convert your Jupyter notebook to a Python script, so that you can run it on a scheduler or something else. Like suppose if you want to run it routinely, automatically, like so then once your program is debugged and it has reached certain level, then you can convert it to a Python script. So when you are going to start writing the program, so Jupyter notebook is the best option. So it supports multiple programming languages as well, like R or Python. So this is the advantage of using Jupyter notebook. So today, and there is an IDE called Visual Studio Code. So we will be using Visual Studio Code for writing programs. So we will be using Jupyter notebook in Visual Studio Code. So I will explain how do we download, install, and configure Visual Studio Code for writing, for using Jupyter notebooks. So Visual Studio Code is a lightweight but very powerful source code editor. So Visual Studio Code is a lightweight but still very powerful. So I think it's some 100 to 200 MBs executable file. So once you install in your system, it gets installed there, but it has a lot of features. It is a very powerful source code editor. So it is available for all the operating systems like Windows, Mac OS, or Linux. For all three operating systems also, this Visual Studio Code is available. So what are the different features? Why are you using Visual Studio Code? First thing is it supports multiple programming languages. So if you see here, it supports these many programming languages: Python, C, C++, C#, Java, Go, Dart, PHP, Ruby. So these are the major programming languages which Visual Studio Code supports. Then these are the features: autocomplete and IntelliSense. So once you start writing code, it gives you auto completion feature plus IntelliSense. IntelliSense means once you type the name of some package or something, so it gives which all functions are available into that package, the documentation on that package, and so on. So it has a feature of autocomplete and IntelliSense. Then enhance completions with AI. So all these auto completion features are powered by a backend AI. Plus it supports linting. Like if in your source code there are some syntax errors or some errors, so these errors it gets highlighted using linting. So like if there is some variable which is uninitialized and you are using it, so then it gives you a warning like thing. Then you can debug your code quite easily. You can switch over to the environments easily. Plus it supports Jupyter notebook as well. So we'll be using Visual Studio Code with Jupyter notebook for writing our Python codes. So let us see how do we install Visual Studio Code. So if you search on the Google, Visual Studio Code, so then you can just download the Visual Studio Code for your environment from here. Now, like if you are using Windows, you can just download here and install. Once the Visual Studio Code is installed into your system, then if you start Visual Studio Code on your start prompt, Visual Studio Code, then it starts Visual Studio Code. So first thing before using Visual Studio Code, like as I explained that Visual Studio Code supports multiple programming languages. So first suppose if you want to write Python codes in your Visual Studio Code. So first thing you need to install the Python extensions in your Visual Studio Code. So here you can go to this tab, extensions. So you type here extension, and here you can search for Python. So here you can see that this Python, and actually in my system it is already installed, so you can just, instead of uninstall, you can just install it. So once the Python extension is installed, so the Jupyter this Visual Studio Code is ready. You are ready to write Python code now. So once the Python extension is installed, then another extension like Jupyter you need to install for getting the support for Jupyter Notebook, like Jupyter. So you need to install this Jupyter extension as well. So once Jupyter and Python extensions are installed in your system, you are ready for writing Python or writing Python code in the Jupyter Notebook. So once this is done, now let us see how do we start writing Python code in Jupyter Notebook. So I will write Visual Studio Code. So once Jupyter Notebooks are, then you can select actually multiple themes from here and so on. So first thing, suppose we are going to use directly Jupyter Notebook. So file, then you can say new file, and from here you can select like Jupyter Notebook. So IPYNB support. So you just hit Jupyter Notebook. Then here it shows like different, like in your system there may be multiple Python interpreter available. So from here you can select the kernel which you want to use. Like suppose if there are multiple Python interpreters available. So base Python and GeoPython. So suppose if I want to use just base Python, I will just click on base Python, and here I can start writing the code. So first, before that, I will just give you the brief overview of Jupyter Notebook. Actually, in Jupyter Notebook, there are two types of cells. I will just increase. So basically, in Jupyter Notebook, there are two types of cell. One is called code cell, and another is called text or markdown cell. So in the code cell, you need to write executable Python code. And in the markdown cell, you can insert images or write some markdown text, or that I will show like in my notebook. You can write headings. Like in markdown cell, you can write formatted text, or you can insert string images as well. There you can insert visualizations. So for creating a new cell here, like suppose if you want to create a markdown cell, you can just click on the plus code, so it inserts a new cell. Or suppose if you want to create a markdown cell, you can create plus markdown. So here, so in the code cell, you can write executable Python code. Like here, I'll write. So for increasing the font size, you need to go view appearance, zoom in. So as I explained, so from here you can delete the cells. So plus code. So like this will be a executable Python code. So if I write here print, same thing, HELLO, hello world. So this shows print hello world. So this is an executable Python code. Now how do I run this particular cell? Either I can shift enter, or I can click on this. So then this particular piece of code gets executed. So there are like the different options available here. You can clear like once the because it is saving in the intermediate output as well. So like once you have run your notebook, you can clear all the outputs. So sometimes what might happen, your kernel may get hanged. So you can restart your kernel by clicking on the restart. So then you can like change settings. So you can change the layout and so on. So those features, actually there are a lot of good videos available on the Microsoft's website. So you can explore more features of Visual Studio Code by going to that link. So basically there are, I will be discussing how there are two types of cell, code cell and markdown cell. In the markdown cell, whatever you write, it will be in formatted text. Like you can write HTML code elsewhere. As you suppose if I want to insert something markdown text like this, suppose I want to write it as a heading. So to hash, this is a heading. Right. Or suppose if you want to insert a new image here. So you can say like I say markdown, and suppose if I have a snip and sketch. Now I want to save this image to my notebook. So I can copy this and I can paste it here. Here you can say that I can write in the same notebook executable Python code as well as text or images and so on. So this is now once you are done with your code, then you can save. So file and save. So you can save your file from here. So anyway, so this was the basic introduction to Jupyter Notebook. So now we will start basics of Python. This is the way we are going to write our code, and let us see. So for this code, actually I have written few samples in a Jupyter notebook. So I will be exploring, opening that notebook and explaining the features one by one. So file, then I will go open, and I have file here. So clear all outputs. So we'll start with the basics of now once we are comfortable with how do we write executable Python code, we will start with the basics of Python. So in any programming language, the most basic thing is a value. So value is a fundamental thing that a program manipulates. So a value can be like a hello Python 1, true. Values can have types. So value is any fundamental thing in a program. So the program will be modifying these values in some way to get the desired result. So that is the most fundamental thing in a program. Program will be, so in our program what we will be doing, we will create some value, and with the help of instructions we will be modifying these values to reach our result. So value can be anything, like you can say hello Python 1 or some true, false. So these can be this can be a value. So the value can have a type also associated with that value. So like you have written hello Python, or we have written hello world. So these are the values, or like 1, 2, 3, these are the values. So our program, we will be manipulating these values in some way. So this is value. Then what next thing comes? Variable. So variable is the most powerful concept in a programming language, is that of a variable. So before that we saw a value. Now suppose we have some value, but in our program we need to associate some name to that value. So that is called a variable. So variable assigns a name to a value. So variables are nothing more than a reserved memory location that stores a value. So actually what happens, these values get stored in somewhere in the memory. So variables are the references to those memory locations, so that in later on our program, by using these variables, we can refer or modify these values. So in Python, variables does not need any explicit declaration to reserve memory. So in other programming languages, if you have used programming language like C, C++, so we need to, when we are going to define a variable, as I explained, that variable has an associated type as well. It can be a numeric value, or it can be a string value, it can be a Boolean value, or it can be a list or sequence type. So in Python, when we define a variable, we need not define its type. We need not explicitly define. We do not need explicit declaration to reserve memory, unlike C, C++, Java. Unlike C, C++ and Java, variables can change the types. As we explained that the variable will have a type as well, but in other programming languages, once a variable is declared to be a type of integer or floating point, later on in our program we cannot change the type, but in Python we can change the type of a variable as the program proceeds. So how do we create a variable and value? So first, like if I see here, like hello Python, this is a string value, just a value. Okay, so if I run this code cell, it prints hello Python. Now suppose if I want to assign this value to a variable, so like I have written a variable called, I have created a variable called message with name message and assigned it value hello Python. So in other programming languages like hello Python, this is a string, so you need to explicitly type like string message, but in Python we need not define the type of the variable, we can just name the variable and what value you are going to assign to it. Like I have written message equal to hello Python. Now once I run this code cell, now if I type here print message, suppose if I want to print the value of this variable, I can say print message, and it prints the Python. Now suppose if I want to know what type of value this variable is holding, so then I can say like type message, so it says string, so str, so this message is holding a string type of value. So next thing comes data types. So Python has multiple data types, as we said that a value can have a type. So the types value can be of different types. So it can be a numeric type. Numeric types can be integer like 92, 12, 0, 1, or they can be floating point numbers like 3.145 and so on. Or these numeric types can be complex numbers of the form a plus ib or so on. Or numeric, or it can be booleans, true or false. 0 means false, 1 is true. Or the type of value can be string like hello Python, name of some person and so on, like name of a country, India. Or it can be sequence type, like when you have multiple sequences, a type of list 1, 2, 3, 4, 5, tuple or ranges. We will discuss these sequence types later on this. Now similarly, like how do we create different types of variables? Now here you can see that we have written x equal to 1. So we are assigning variable x the value 1. So we are assigning an integer type of value to variable x. So now suppose if you want here in the second statement we are assigning like y equal to x plus 5. So the value of x, so actually if you are new to the programming you should not get confused with this equal to operator here. So this in mathematics equal to, this single equal is a comparison operator, but in case of programming language this equal to is an assignment operation. So here what we are doing, we are assigning value 1 to variable x. So similarly y equal to x plus 5, z equal to y. So then if suppose a is of floating point type, then a equal to 10.5 or boolean value or floating point value. This way you can create a variable expression. So if I type here this, so now here you can say that x initially was of type integer, but later on we assigned it the value of floating point type as well. So in Python is dynamically typed language, so we can change the type of variable as the program goes. So this way we create basic variables. So name of the variable and what value we are going to assign to it. So similarly, now suppose if you want to create a string variable, so we'll discuss in detail about string variables. So string variables, whenever string variables you need to, string values you need to define in single quote or single double or triple quote. There are multiple options. So like x, if I want to assign the variable x the value hello, so I can write x hello. Then if I cite like type x, it says class string. So similar way, so actually there are different conventions for naming the variable. So variables you can use, I think the length of, there is no limit on the length of variable name. You can use, then few special characters also you can use, like underscore. Underscore is a special character you can use, but the name of the variable cannot start with a numeral. So like here name 1, name underscore 1, name underscore 2, but you cannot give like name dash 1. So this you cannot use. Only the special character underscore you can use for naming the variables. Name of any arbitrary length you can, like here we created a variable with two variables, name and name 1, but the variable name cannot start with a numeral. So you cannot give a variable like one name equal to Python. You cannot create a variable with one name. Then there are few keywords. Actually in Python there are few keywords. So those are reserved for Python interpreters. So those name also you cannot use for creating variables name, like def. So the list of all keywords is available in python.org. You can just refer to that, like def, if, else, elif. So there are switch, and there are multiple keywords that you cannot use as variable names. Like if I want to create it, I want to define a variable named def, but I cannot do that because def is a reserved keyword. So def equal to 10 will give, compiler will give an error. So similarly, as I explained, that we can change the type of variable as the program goes, like here x equal to 1, then we have assigned it a floating point value, then again an integer value. So this way in last, if I type print of type of x, it says integer. So similar way I can assign to x value like boolean values x. So here type of x, now later on we change it to type boolean x when assigned true. So capital 2. Actually Python is a case sensitive language. So you must like capital true and small true are totally different. So if you want to use true, then you must use capital T. So this way you can create boolean variables as well. Now if I see the type, initially x type was float, then we changed it to the boolean type. So similar way, suppose if you want to create a string. So string values are enclosed in a single, double or triple quotes, and numerals are not enclosed in any type of quotes. So this way you can differentiate between the integer value or string value. Now here you can say x, this is a string, is a character array of characters or set of characters. You can say this is a string. So x is equal to 10. So this is a string variable. So if I type print x, it prints that this is a string and type of x. So similar way, suppose if you want to add two strings together with plus operator, you can concatenate multiple strings also together. So similar way, suppose if you want to store integer floating point like planets in solar system. So for that the default choice will be integer type. So planets in solar system equal to 8, or distance to Alpha Centauri 4. This will be a floating point number. Or can the vehicle lift off? So this may be a boolean type. So depending on your requirement, you can choose like true, false or string what value you are going to store. So this is how do we create variables in Python. So just name of the variable and the value what we are going to assign to it. So then there is a concept called modules in Python. So module is a file containing Python definition and statements. So what happens, like suppose you have written some Python code and you want to distribute to some other persons because you have written some piece of code that may be useful to other people as well. So you need to distribute it to other people so that they need not rewrite. So what you will do, you will write your code in different files. So that file will be called a module. So the other person can import that module and use the functions written by you. So what happens, not all, even Python interpreter has a lot of functionalities, but because all functionalities may not be required by all the programmers. So what happens, by default, not all functionalities becomes available automatically when we start a Python interpreter. So extra functionality can be added by importing modules. So when you start a Python interpreter, only basic functionality which is must for Python to get started, only those functions get loaded. So if you need new functionalities, that you can import that specific module and use that functionality. So objects, suppose if you want to access any objects in that module, then like you need to give like module name dot that function. Like suppose by default all math functionality is not available in the Python interpreter. So suppose if I want to import math functionality in my module, so I need to import that math module in the Python interpreter. So I will write like import math. So with this, all math functionality becomes available to my Python interpreter. So now suppose if I want to use the functions available in this math library, then I can use like math dot. So if you see in a Jupyter notebook, so if as just I type math, so it has listed me all the functions available in the math library. So like if I want to use power function, so math.pow a function, then if you see this, then you see the documentation around this function as well. So what it says, math.pow, it returns x raised to the power y. Actually, when we talk about operators, then you will come to know about this double star operator. So like this math function and 2, 3, so it returns 8. So similarly, now suppose if you want to use the random numbers library, so then you can use import random, and suppose if you want to generate random integers, so there is a function called random.randint. So it generates random integers, rand int. So now suppose if you don't know anything about this function, so then you can read about the document. It's like random integer. It returns a random integer in range a to b, including both endpoints. So it generates a random integer in this range, like 1 to 10. So in this range, it will generate a random number. So similar way, there are two ways to import two functions, like import random, or there is another syntax for importing like from pathlib. So from the module, suppose directly like from random import randit. Also you can do like in the pathlib module, there are multiple functions available. So if you want to import only particular function from your total library, then you can write this way also, from pathlib import path. Then in a Python programming language, a comment means that if a line is preceded, any line of code in the Python code is preceded with a hash, so that will be treated as a comment. So this will not be executed by the interpreter. So if you want to make any line in your code to be a comment, then you need to proceed with a hash. So all the comments start with a hash. Now this way we have seen that how do we create variables, different type of variables, how do we import different other modules and so on. Now we will put these all things together and write a simple program using Python. Now suppose if you've been given a task to write a program to calculate simple interest. Now for calculating a simple interest, you need to know different things first, like what is the rate of interest. So rate of interest, principal amount, and for how much time you want to calculate the interest, right? So here I have created a variable called rate. I have assigned it value 10. So for 10% annual interest rate, and I have created a variable called principal. So for 1000 rupees, this is 1000 rupees is the principal amount. Then for time, 3 years. So for this, I suppose if I want to write a program which calculates the interest for given rate, principal, and time. So I have created 3 variables here. Then for calculating interest, I have created here a new variable called interest. Like I will write rate into principal into time divided by 100. So that is the formula for calculating the interest. So now that is done. So that it will get a value. So now that value we need to store in a variable. So the value calculated by this formula will be stored in the variable called interest. So later on we can refer this. Like if I do this, and actually this has not run. So shift enter. If I write interest, so interest is calculated. Now suppose if I want to print the value of this interest, I can see it like print interest is. So this interest means this is a string variable that I want to print with my interest variable. So interest is final variable. So print can take multiple arguments. We will be discussing on this. So print interest is interest. So it says interest is, then this particular interest is 300. So this way we can put all these building blocks together to make program. So print function. So now there are different operations available in the programming language. Like suppose if you want to add two numbers, you want to do addition operation. So simple plus operator, like answer equal to, you want to add two numbers, answer equal to 30 plus 12. So then you can say print answer. So then other variable like difference, suppose if you want to calculate difference between two numbers, so minus is the operator. So a minus b, then you can print difference. Then multiplication, if you want to do the operator, multiply operator. Then for division, slash. So actually by default Python in Python 3 onwards, 30 by 12 gives you floating point number. But suppose if you want only integer portion of this answer, so then you can use this double slash operator. So like suppose if there are 1042 seconds, now these seconds you want to convert to minutes. So we want to just exclude the seconds portion after, or what you call remaining portion. So you can use double slash. So it just gives you the integer part. So 1042, you can see the difference between these two. Here it has returned 17. If I see this, it will return 17.366. So if you just want to return the integer part, you can use double slash. By default, it returns floating point number. So similarly, like there is an operator called modulus operator. So suppose you have number of seconds 1042. Now this you want to convert into minutes and seconds. So 1042, if you divide by 60, it gives you the number of minutes, and the remainder gives you number of seconds in that. So this way sorry, so this way you can say that number of seconds. So 1042 seconds means 17 minutes 22 seconds. So similar way you can calculate any operation, like suppose if you have a launch vehicle. Now you know the end velocity of that vehicle and start velocity and what acceleration it is going. So suppose if you want to calculate the time to reach the desired velocity, so that like suppose your vehicle is starting at the 0 velocity and you want to reach at 60 km per hour, and the vehicle is accelerating at 9.8 km per second square. So same thing, like you want to calculate the time, you can say like time equal to, how do you calculate, end velocity minus starting velocity divided by acceleration. So that gives the time to reach to that velocity. So this way you can do any kind of calculations. Then there is one more important thing in Python is indentation. So in other programming languages, the blocks of codes are identified or delimited using curly braces or some kind of other braces. But in Python, block of codes are defined using indentation. So any line that is at a bigger indentation level means if there are number of spaces left in this some line and the next line to this, so means that that particular code belongs to the previous block code. So in the example you will see, so in Python block of codes are defined using indentation. The indentation within the block needs to be consistent. Actually you must follow the same indentation level between the block of codes. Like suppose if in your block there are 3 lines, so all the 3 lines should be at equal space. So the first line with less indentation is outside the block. So the line which is at the higher indentation is inside that block, and the first line which is at the less indentation level is the outside that block. So often a colon appears at the start of a new block. So let's see the code. Like here you are seeing. So as you say, this indentation level means like you can say the number of spaces. Here we have written like x equal to 12. Now suppose if you want to delimit a new block of code, so here you have written x equal to 10, and we want if x is less than 10, then only these 2 lines should be executed. Means these 2 lines are the part. Suppose if you want to make it, because in Python there are no curly braces for defining a block of code. So indentation level, because these 2 lines at a different indentation level from this line, so it means these two lines are the part of this block. So if x is less than 10, these two statements will get executed. So if any line that is coming at this indentation level means this block is completed now. Now this will not be the part of this block of code. So now if you see here, x is 12. Now we have written like if x is less than 10, print x is less than 10 here, then this is conditional statement. So when if x is less than 10, then only these two lines will be executed. So you can see that because x is greater than 10, so the interpreter did not execute these lines. So for making a block of code, different indentation level. Now suppose if I write the code here, print outside the if block. So because this line doesn't belong to this block, so because this is at the different indentation level compared to these two lines, so this is outside this block. So any line which is at a different indentation level is outside the block. So in Python, general convention is supposed to use, actually for a new block of code you must leave 4 spaces, so that instead of leaving the tab, actually even you can leave 1 space also, but for better looking code, or if you are going to follow the standard convention, you must leave 4 spaces for the indentation level. So similarly, like here, if we have written we have defined two variables a and b, like here we have written if a is less than b. So like if you want like this statement to be executed when a is less than b, then print b. So here you can see that the value of a was greater than b. So this statement did not get executed. Similarly, now suppose here we have written defined two variables a equal to 24, b equal to 44. Here we have written if a is less than equal to 0. Anyway, a is less than 0, it prints a, and later on it prints b. So both the values will be printed. A is less than equal to 0. A is not less, sorry, a is not less than 0. So this statement got skipped and this line got executed. So similarly, suppose if you want to write else, so a is 97, 93, b 27. If a is greater than equal to b, then print b. Or suppose in else, if you want to write this way also you can write. Now suppose if there are multiple conditions in else, so like if a is greater than b, then if print a is greater than b, elif. So if a, then you can write elif also. So like multiple conditions you can club with elif. Then there is an else also. So if a is greater than b, print a is greater than b, elif else also you can write this way, multiple if else's. So similar way in elif also you can check multiple conditions once again. So there are two other operators, like suppose sometimes writing this type of code becomes quite cumbersome. So there are two operators called and or operator. So here you can see that this I have written in a markdown cell. So like here if I have a equal to 23 and I have a variable called b equal to 34, and I want to check like whether if a is equal to 34 or b is equal to 34. So either of them is true, then I just want to print a plus b. So here b is 34, so any of them is true, so this becomes true. So if any of the condition is true and you want the statement to be evaluated true to true, then you can use this. Then there is another statement called and. So and evaluates to true only if both the conditions are true. So a equal to 34 and b also is equal to 34, then only this statement evaluates to true and it prints a plus b. Then this is strings. So strings are text values, like you say hello anaconda or so on. So then strings can be enclosed in a single quote, double quote or triple quotes. In Python, strings can be enclosed in a single, double or triple quote. Now suppose if you want to, here we are suppose if you want to store this, the moon has a radius of 1080 miles in a variable called moon radius. So you can create like moon radius equal to this. And suppose if I print this, it prints moon radius. Similar way, suppose if you want to actually you can use single, double or triple quotes. Suppose if you inside in your string string itself, suppose it contains double quotes, then you must enclose your string in a single quote, or vice versa. Like suppose if I want to print the fact, like here you can see that the near side contains a double quote itself. So that in that case you must enclose your outer string in a single quote. So if I print the fact, it says here double quotes are inside this. Similar way, now suppose if you want to write a multi-line string, so then you can use double or triple quotes. So when your string is in multi-line, you can use triple quotes. So when you use triple quotes, the line can span over multiple lines. Your string can span over multiple lines. So when you are going to use multiple string with where string spanning over multiple lines, then triple quotes you can use. So suppose if you want to check whether like some text is there in your string also, like suppose moon in. So in this text will describe the fact and challenge the space travel. So it will search for the moon in this particular string. Then you can use in operator. So in this particular string there is no moon string in there is no moon substring in this string. So it returns false. Like if I write here moon in, so here moon is available. So this will return. So this is checking for this particular string in this bigger string. Similar way, like suppose if you want in a string you want to search for some substring, so then you can use like find. So like in the temperature strings, suppose if you want to find moon is occurring or not, so you can use find also. But moon find. So if it returns -1 means it could not find the moon substring in this temperature string. So similarly, like suppose if you can, like Mars is available, temperature dot Mars. So it says that at 82nd location Mars substring is there. Similarly, now suppose if you want to count like how many times Mars string is occurring in this temperature string, then you can count Mars. So there are many more functions available in the string library. You can go through the documentation. Similarly, like there were no moon, so count it gives 0. And similarly, now suppose if you want to convert it to lower, upper, so many things are there. If you want to convert into lower case, you can call dot lower or dot upper or capital string sentence case. So there are many functions available on this. Then one more thing is like strings can be indexed with first character having index 0. So when a string is there, so strings can be indexed. Like here word is equivalent in Python. So if I type word 0, it gives P. So this 0, 1, 2, 3, 4, 5. So the strings can be indexed with number 0. So word 0 gives the first string. So similarly, like word 5 will give the last string. Then in Python, strings have a negative index also. So -1 gives the last string and so on. -1 will be the last character. -1 is giving word, -1 gives the last character, word -2 will give the second last character, and so on. Plus you can use slices also, like if you give word 0:2, so it gives from 0 to second index. So pyt, it will give you py, and 2 and 5 similar way. You can slice the string as well. Then suppose if you want to multi-line string can be used with this way also, by with plus operator also you can use multi-line string to text. So then there is another data structure in Python called list. List is the ordered sequence of information accessible by index. So suppose you want to store the names of all planets in our solar system. So you cannot store them in a single variable, or you cannot create a different variable for a different planet. So what we can do, or suppose if you want to store the name of all students in a class, so what you cannot create a different variable for each student. So you can create a list. So So list is a sequence, ordered sequence of information accessible by index. Now here you can see that suppose if I have created a variable called planets in which I am storing the name of different planets. So how do we create a list? List can be created using square brackets, and inside that all elements or different elements separated by a comma. So here we have created a list of strings. So like here you can see that this. So now this list can be any elements of the list can be accessed using its index. So suppose if I want to access the 0th element from this list, so planet 0, 1, 2. So this Mercury will be 0, Venus will be 1, and Mars will be 2. Now suppose if you want to change the value of any of this planet, so like you can planet 3 you want to Mars you want to replace with red planet. So then planet 3 equal to red planet. If you do, planet 3 value gets replaced with the red planet. Now if I print planet 3, it gives red planet. So suppose if you, then there are multiple functions available in the list like length. So length calculates the length of the list. So number of, like suppose if you have stored them, now you want to know number of planets in your list. So you can just call length planets. So then if you print it, there are number of planets, or there are 9 planets in our solar system and so on. So suppose if you want to delete some item from the list, then you can call pop function. So pop will delete the last element from our list. So planets.pop. So one item got removed from this. Now instead of 9 or 8, now there are 7 planets. So we have stored 8. Now Pluto is removed from this. So then this way you can pop anything, and then so similar way, like you can, indexes are there. So same indexes as in string. So -1 refers to the last element of the string. So -1, -2 and so on. Similar way, now suppose if you want to search for some element in your list, so you can search for like planets.index. It gives the index of that element in the list. Similar way, similar to the list of strings, there can be a list of integers, floating point numbers and so on, like gravity on planets, bus weight. So like this way you can access any element of the list. So like if you want to calculate the minimum maximum so of the list, so you can call min function or max function on the list. So similar way, you can, similar to the strings, you can slice the strings, and suppose if you want, you can concatenate 2 strings together, like we have created here 2 strings, and then we can combine these 2 strings together to create a new list. Suppose if you want to sort, so sorting also is possible. So suppose you have a list and you want to sort them. So that's just on the list you can call the sort function. So it sorts the entire list. And similarly, suppose if you want to sort the list in a reverse fashion, you can call dot sort with reverse equal to true. There is another data structure similar to list is called tuple. So tuple consists a number of values separated by commas, similar to a list. Cannot change element values. This is immutable. Actually, in the list, actually you can change a variable, you can add new values to the list and so on. But tuples are immutable. Tuples always are enclosed in parentheses. So this tuple can be used to return one or more values from a function. So how do we create a tuple? So a list was created by creating parentheses, square brackets inside that element, but a tuple will be created by, say, this simple way you can create, or you can put parentheses or no parentheses. So their list was created using square brackets. So tuple can be created using parentheses. So this is a tuple with 3 elements. So elements of tuple also can be accessed, the similar can be indexed, like T0 will be given to give you the first element. Then you can nest tuples like T, 1, 2, 3, 4. If you do, now you can see that this 1, 2, 3, 4, 5, hello, and second. So now these two tuples got concatenated. But now because tuples are immutable, once some value is assigned to an element in the tuple, it cannot be changed. Now suppose if I want to assign t0 a new value, so the interpreter will give an error. Similar way, tuple can be unpacked as well. Like suppose if your element tuple was having 3 elements, now you want to assign these elements to 3 different variables. So you can just write a single statement x comma y comma z equal to t. So this tuple gets unpacked down, all values get assigned to the different variables. So here you can see t was having 1 2 3 5 4 5 4 3 2 1 and hello. So a single value got to 1 2 3 4 5 went to the x, second value got to this. So this is called tuple unpacking. Another data structure is set. Set is an unordered collection with no duplicate elements. So set objects also support some mathematical operations like this. Set is quite similar to the mathematical set, union, intersection, difference and symmetric difference. Like here we are set will be created by using curly braces. So here we have created a set of basket, apple or apple. So here you can, as we said, that set is an unordered collection with no duplicate elements. So in basket we created multiple apples. So once you use multiple apples. Now if I similar way, now basket, and I have created here another basket list. So this is a set and this is a list. So now if I print the basket underscore L is a list. So here you can see that. So though in our while creating this we defined apple twice, but when we are printing this basket, apple gets printed only once. So set automatically removes duplicates. But if I print basket underscore L, it will print apples twice. So here you can see that apples are printed twice. So when you want to remove duplicates automatically, you can use set. So similar to for checking the membership operation, you can check in operator like orange in basket. If orange in basket true or false, it says true. Like if I want to say search crabgrass in basket, because crabgrass we have not set in the basket, it says false. Similarly, you can create a set using these functions and you can do the mathematical operation like A union B, A minus B. So suppose if I want to calculate A minus B, elements in A which are not available in B. So if I run this B, D and R. So if you see B, D and R are not available in A. So it gives, so this way A plus B, A minus B, A union intersection, any operation which is applicable on set can be applied. So the next data structure in Python is dictionary. So dictionary is a set of key value pairs. So when you want to store related data together like name and roll number of a student or name and phone number of some person, so then dictionary is an appropriate data structure to be used. Is it a set of key value pairs? Dictionaries are indexed by keys which can be of any immutable type, and dictionary stores a value with some key and extracts the value given in the key. Like how do we create a dictionary? Suppose if I want to store the telephone numbers of different persons in my organization, so I will write like telephone equal to in curly braces first key colon pair. So if you see in the case of set, there were this colon was not there. So all elements were separated by comma. Here also elements are separated by comma, but here every element is a key value pair separated by a colon. So like Jack, his phone number is this, say phone number is this, alpha, beta. So this way we create dictionary. Now suppose if you want to search the telephone number of Jack, so you can say our variable telephone in square brackets the name of key. So Jack gives the telephone number of Jack. Similar way, now suppose if you want to add a new entry to our telephone book, so like if you want to add the telephone number of King, so telephone King is equal to 4127. So it creates a new entry in our dictionary. A similar way, now suppose if you want to create delete something from the dictionary, so then you can write del telephone of SAP. So this gets deleted. Now if I print telephone, SAP will not be there in this. Similar way, for checking the membership, you can check whether suppose you want searching for whether someone's name is there or not in the dictionary, then you can search in operator. Similar to suppose some there are certain loops in the Python. How do we write loops? Suppose something you want to do repeatedly until some condition is true or false. Like you don't know how many times your loop needs to run. So in that case you can use while loop. So how do we write while loop? Suppose if you are taking some input from the user and you want to check that when the user types done, then only come out of the loop. So like we have created a variable called user input and we have created an empty string, stored an empty string in the user input. So now how do we write while loop? So while the condition you are going to check, like here we are checking user input dot lower is not equal to done. So until whatever user is going to type is not equal to done, it will be iterating over this loop. So once user types done, it will come out of this loop. Like suppose here I am, now it is running, asking for the user input. Like type A, B, it will keep on running. Now if I write done, so then it comes out of this loop. Right. Now similar way, you can store these values to some list and print them as well. Like here, user input dot lower not equal to done. If user had typed something, you are just appending these inputs to a and this inputs list. So like here I will type A, B, done. So then if I type inputs, you can say A and B. So similarly, suppose if you want to use for loop, actually this for loop in the Python is slightly different from the for loop in other programming languages. For loop in the Python is used for iterating over a list. Like here we have defined a list called countdown. So in this we have stored these values. Now suppose if you want to iterate over these elements one by one, so this is the syntax for number in countdown. So number in countdown means it is iterating over the countdown one by one, and the value which is currently iterating is assigned to the variable number. So then we are just printing it number. So once this loop gets exhausted, it is just printing blast off. So number like 4, 3, 2, 1 gets printed and blast off. Similar way, suppose if you want to wait, then you can write a wait statement as well. Now suppose if you want to iterate over a sequence like in other programming language C or C++, suppose if you want to generate a range of numbers from 1 to 5. So you can call like for I in range 5. So when you can use a function called range. So suppose if you are passing a single variable to it, so it starts from 0 and ends to the 5. So 0, 1, 2, 3 and 4. Now suppose if you want to start at some number, start and end. Suppose if you are passing two variables to the range function, then it starts at 5 and ends at 10. And the steps are incremented by 1. And suppose if you want to increment it by 2, then you can pass a third argument also to the range function, like number of steps. So now the I will increment by 2, 5, 7, 9. So then there are two other things in a loop. Suppose if you want to break out of loop when certain condition is meeting, like there are two statements, break and continue. Break statement breaks out of the innermost enclosing for or while loop, while the continue statement continues the next iteration of the loop, skipping remaining statements. So like for example here, if you take, we are writing for I in range to 50. So we want to print here like if I is equal to 4, we want to break out of this loop. So though we have written up to 50, but this loop after 4, it will come out of this. So when I is 4, it has come out of this loop. Now suppose here we want to print, we are just printing the numbers. Only we want when I is equal to 2, we want to skip this print. So then we can write if I is equal to 2, continue. When I will be 2, this print statement will be skipped and it will go to the next iteration. So here if you will see, we will just print 0, 1, 3 and 4. Now we will see that how do we write and write call and invoke a function in Python. So if it so if you find that the same bit of code can be used over and over again, so instead of writing that piece of code multiple times, what we can do, we can write a function, and that function can be called in the different parts of code, right? So how do we write a function in Python? So a function in Python can be written like, can be preceded with a def keyword. So def, then the name of your function and the argument it takes, then a colon, then inside this the body of your function. So here we have defined a function def rocket parts, which prints payload, propellant and structure. So once a function is defined, it doesn't do anything on its own. So what we need to do, we need to call this function. So how do we call a function? The function can be called by function name and a parenthesis. So then so if I call this function, how do we call this function? This def rocket parts. So if I call this rocket parts, it prints payload, propellant and structure. Then the function can take argument also. So this, our previous function was not taking any argument. Like now suppose if you want to write a function to calculate distance from the earth to some destination. So it is taking one argument also. Here we have written if destination is equal to moon, return this, otherwise return this. So a function can return a value also using return statement. So this particular function takes an argument. Now if I call this function without any argument, just with parenthesis, it returns an error. Okay, it says missing one required positional argument. Now if I pass an argument to this moon, so then it returns 2238,885. So it returns this statement. So this way we can define a function. So default value arguments are not important. So next thing is, how do we read and write files using Python? So for opening a file, we can call open function, f equal to open, and we need to give the name of the file which we want to read. Like suppose if we have given this same thing, I will save as D drive work.txt. So how do we read a file? F equal to open, then f dot read. So it reads all the files from the function. So once the file is read, we need to close. So now you see that print hello world, because we had written this line in our file. So it reads the contents of the file. Or suppose if you want to read, because this is okay for when your file is very small. So then you, in this case, f dot read reads the all contents of your file. But if your file is very large and the memory available in your system is very low, then what you can do, you can read the file line by line as well. So the same thing you can follow here, like f equal to open, name of your file, and then for line in the f object, you can iterate over lines one by one. So same thing. Then once the file is read, you need to close it. Similar way, suppose if you want to write something to the file. So like suppose if you want to write this value, the answer is 42 to your file. So you can, same thing, like you can actually there is one thing I missed. There is an construct with construct for reading the file. So what happens, suppose if you have read the file and forgot to close it after reading the file. So what might happen, because it will unnecessarily use the resources of the system and the file may be left in an inconsistent state. So it is better always to read or write the file using a with construct, so that once the code goes out of the scope of this with, the file gets automatically closed. You need not explicitly close it. So how do we use read the file using with construct? So with, then open your name of the file, in anyway you are in the read mode, as f, then for line in f, print line. Then here explicitly we need not close this file. Once the code goes out of the scope of this with, the file gets automatically closed. So same thing here we are using for writing. So this is the value. We have created a value string. In that we have stored the answer is 42. And same thing with open, name of the file, and here we have just changed the mode. Actually open is taking 2 arguments, name of the file actually it takes multiple other arguments. You can just read about that in documentation. Name of the file and the mode. So suppose if you want to open the file for writing, so W as F, then anyway this value we have converted to the string, then instead of read, write, F dot write as, so it writes. So now if you see here work file 2.txt, there must be a file in the D drive. Work file.txt, and in this the answer is 42 got stored. So this way we can read and write the file. So this was all about the basics of Python. So actually it was a bit fast. So if you have done already programming, this may be easy for you, but if you have not done programming before, so I request you all, please go through these once again, or even you can go through the documentation available in the Python and just get familiar with these basic constructs. So these all constructs will be using in our subsequent classes. So if you go through this and get familiar with the basic syntax of Python, it will be easy for you to follow the next sessions. So thank you very much for today. Thank you.